think more, so there's more complex thinking that I'm discussing here. Inferred relationships is what our AI does, and this AI is called Medicare, and it is a knowledge reasoner. So you may be thinking, what do these dots and lines have to do with bioinformatics and biomedical knowledge? So, like I said before, each dot represents a concept, and these concepts can be broken down into different categories. So, for example, there could be a disorder that is known to disrupt a cellular pathway, and a gene that is associated with this pathway. So, there could also be a drug that's known to activate this gene. And these solid lines are represented as evidence in the form of a publication. And between each connection, there's evidence and literature and data that's been provided that really affirms that the relationships are there. However, you can reason or infer that relationships like this gene through its association with this pathway may be related to disorder. This inferred relationship is really important, and it's kind of what we are working on right now. So we can also infer that because the drug activates a gene, it may also be related to the pathway in disorder through its activity in this gene. So first, we're going to go through our process here. And what we do really well right now is review monogenic disorders, which is really a disorder associated with one gene. But sometimes there are several genes involved in the disorder. So we go through the gene, we look at the genetic variant that's included, and any other pertinent genetic information. And then we determine the direction of regulation that we want to act on the gene. So this will be either activate or inhibit, and sometimes it's case dependent and very unclear. So this is where a lot of time is sunk determining which way we want to move the gene or protein. And then finally, we run Medicameron based on the direction that we want to run the gene. And we sort and review hits because AI is not perfect. And sometimes it's on the basis of nomenclature, where a gene may have a similar name that's included as another abbreviation. So in a real life example that I run into, the gene named Capicua is also termed CIC. And there's another term for CIC, which is the citric isocitric carrier, which is completely unrelated. And then also chronic idiopathic constipation is another one. So it's really important to have a human reviewing the hits that the AI pulls. So not quite at the stage where the AI is able to run everything without regulation, and I don't think we ever will be, but this is sort of the process that we go through. So let's look at the type of hits. And by hit, I mean anything that the AI pulls that could be pertinent in diagnosing and treating a disease with the drug repurposing. So first, we pull the hits from our Medicameron, the AI that reasons and goes through every paper that's ever been published. And we look for drugs that either directly interact with the gene or indirectly interact with the gene through an associated pathway. So the direct hit would be considered a one-hop, since it's just one hop to go from the gene to the drug, and then the indirect pathway would be considered a two-hop. So the next thing that I'd like to talk about is something that is currently under development right now. So I'm giving you guys kind of a behind-the-scenes look at something called Pathfinder. Because one question that we're frequently asked is what relationships exist between two genes, and something like what overlap is there between two genes. And a lot of the times there's a biological process that's either shared or involves both genes. And Pathfinder is our newest UI that is tasked with reviewing the relationships between two genes and a shared biological concept. So in this case, the hit would be a process or something in the middle between the two genes that is shared. And a lot of the times this also involves an intermediate gene on either side, gene 1 and gene biological process, or gene 2 and biological process. So this is very interesting information because it informs how we might map out a mechanistic or clinically relevant path between two genes or a gene and pathway. So You may be wondering how we rank hits that we pull from our Medicare, the drugs that come up as results when we're looking for potentially repurposable drugs. Medicare uses publications to rank drugs. So the more publications the drug has, the higher Medicare will rank it. And this is important for prioritizing or triaging drugs in an instance that you might not have every dollar in the world to throw at a mass drug screen. So this is sort of how the AI informs which drugs might be best fit for a drug repurposing screen. So getting into Medicare in action, the first thing that I did, since I'm kind of over Champ 1 at the PMI at the Precision Medicine Institute, was run Champ through our Medicare. And unfortunately, after our initial analysis, we didn't have any direct hits or approaches on regulating Champ 1. So we took a step back and looked at the genes that are dysregulated as a result of a variant in Champ 1. In this work, the identifying which genes were dysregulated was done by T. Wen. She works with us very closely, so she provided the RNA-seq. So that's a pretty good attribution that I actually give. But looking at these genes with altered expression, we wanted to find a drug that would preferentially regulate as many genes as possible, or the most pertinent genes in a direction that brings them closer to baseline or to a wild type of like a healthy cell. So we used metformin. We used the AI platform Medicare that identified metformin among other drugs to complement the expression of genes and move them more towards a natural level. So this is sort of the hit that we have for this case, which would be metformin. There are other compounds and drugs that we've found, but it is important to note that much more preclinical testing needs to be done before this can be acted upon. This is all very preliminary data and really isn't immediately actionable. So using the newer AI, the UI that we've developed, Pathfinder, I want to look at Champ1 and POXI to see what relationships they share. So this is the sort of the first result that we have, and this is a screenshot from the UI. So it's a pretty friendly interface, easy to access and use. But there are many cellular processes that are shared between Champ1 and POXI. So just picking one, like mitotic assisted repair on the top here, we can see that Champ1 is involved in this, and so is POXI. And then looking a little bit closer, this is what the AI is drawing between both Champ1, POXI, and the relationships that it draws. So you can see that it's a very encompassing and a pretty immense graph that draws several relationships almost instantaneously between both genes and process and the two target genes that we're looking at as well. So importantly, we found NSL1 and MIS1, 2, are both involved in this pathway as well. So any researchers in the room, if this is interesting to you, I hope so. And while this is still under development, it can't produce papers quite yet, so that's why this is kind of behind the scenes. I haven't presented this anywhere else, so you guys are actually getting the first look at this. We are always looking for more users, because the more you use an AI, the more data it can accumulate, and the smarter it gets. So anyone that is interested in trying this out, please use this QR code to go to the link. You may need to use it on your desktop or laptop, because I'm not entirely sure if it is iPhone or mobile friendly. But it's always great to have more data, and so please use this as much as you would like. And as a disclaimer, this is a research tool and is not intended to be used as a clinical service. Like I said, there really needs to be human interaction with the results that we pull, because they are not perfect. So with that, I'd like to open up to any questions that anyone may have. And I'd also be happy to discuss more later on during like a networking session as well.
Where do you get your databases from? Do you build them up? Are they public? Here. Hey.
Oh, perfect. Hi. Yes, so we pull from PubMed, and that's where we get the majority of our literature from. And I believe there are a couple drug databases that we pull from as well. So that's where some of the inferred interactions come, where there's not really a publication to link a drug and a gene, but rather there's the data is out there. It's just not in a publication form.
Okay, thank you for presentation. Drug repurposing obviously very important and saves time and money. So my question is, have you evaluated your, I don't know, tool for some well-studied common diseases like cystic fibrosis or diabetes, so you know you're getting the right hits?
We have. I have not personally because I jumped in with the program when we were moving towards rare disease. Um, and that is pretty much the basis that anyone in our UI and development team uses to check whether or not we're pulling what we need to. So we do frequently. We use diabetes as a common one, cystic fibrosis, like you said, both monogenic and polygenic conditions.
Hi. So as someone who's probably interested more in terms of like the interactions found between the genes, is it possible to get some visibility on like the literature that kind of supports those connections?
Yes, absolutely. So the what we have now, these interactions are not supported by literature necessarily because the development team and the UI team have not got together to establish that. But what it'll eventually look like is closer to like our like normal hits, I guess, like this. So each of these right now, using Metacanron, can pull a publication for the literature that supports this. Right now, the Pathfinder, where we're looking at 2 genes, doesn't necessarily, but it's under development and it should be done, pretty soon.
Hi.
Hi.
Were there any drug hits found for POGZ yet?
We're looking through that, and if Swapna is in the room, I think I've met with her recently. Another analyst performed an analysis for proxy, and I believe there was one that was found. But I hesitate to bring that up because it's not immediately actionable, and I don't want to put a lot of weight on it as well. But we did run through, and we found a few hits that were interesting. So I hope that's helpful in a sense.
Yep, thank you.
Hmm?
I was just when you had that that cross very last slide, I noticed some of the researchers sneaking up there. I was wondering, is there a reverse notification procedure, like whoever was the author for study number or whatever there, they get dinged that, hey, we just made a connection with some of your research, and they look at it and say, oh, I don't care about that, or, oh my goodness, I could figure out something with that. Do you do it backwards?
We haven't yet, mainly because this is such a new UI, and it's really still under development. But I believe there are other platforms that do that. So I think like Gene Matcher, if you look at a gene and investigate it, you can notify a researcher that you're working on the gene. So I think that would be interesting, and I'll bring that up with our UI team and see if we can add that. But right now, no, just mainly because we're still in the developmental stage.
Hi, thank you for the talk. I'm wondering if your algorithm uses the genes and the pathways that are mentioned in manuscripts and in figures, or is it able to also dig into the like supplementary data and the raw data to really draw connections?
It can, yeah. It uses supplementary data, and that's part of the reason that we still need people to review hits, because a lot of the times the paper itself won't reference a gene, but in the supplementary data with 1,000 genes, it'll show an interaction like a log change based on drugs. So it pulls a lot. What Dr. Might, our director, says is it indiscriminately pulls data, so it's just every drug that's ever been found to have an interaction between a gene. So that includes a lot of drugs. So.
Thank you. When you say there's a connection and it preferentially regulates, is there a threshold for how much it needs to regulate for it to count, or what kind of outcomes you see when it regulates?
That's another thing that a human reviews right now. So what we find is just anything that changes in a direction. So that could be a fold change of 0.1. So it could be a really minuscule change, and that's why we review it as analysts and as researchers to examine whether or not it really does. So in this case, the list that we had of drugs that preferentially regulated the RNA-seq data, the genes that were differentially expressed, included a lot of drugs, and there were hundreds of them, but not a lot of them really did what would be clinically relevant in the case of CHAMP1. So that's sort of what we review, and that's why metformin was found to be interesting. There were others that were found to be interesting based on the kind of the potency of what they did.
I have a question, but it might not sound quite as educated. So when you said metformin regulated or affected the genes, what exactly does that mean? Like, that's a drug that can be used and helpful with these two syndromes, or it shouldn't be used? I mean, what effect does it have on the genes? So
we are way too early to assume that it has clinical relevance, and that's a very important step. The relevance we have here is that looking at the expression of genes in the context of a CHAMP1 variant, these genes are disordered. The expressions of the genes are not as what they would be in a case of no CHAMP1 variant. So what we did was look at these genes and then try to find a drug that can move them closer to what a normal state would be without a CHAMP1 variant. And metformin was found to do this, but that doesn't mean that it would necessarily have a direct clinical application yet, and that's why we really need to do more preclinical testing. So right now it's just on the basis of a mechanistic relationship between the genes and a drug that supposedly would regulate the genes in a correct direction.
In this study, do you have links then of drugs that work not necessarily to normalize the gene, but for other side effects or comorbidities that people with these syndromes have? So like, okay, this is a drug that has been working for a lot of people with the syndrome. We're getting hits on this. So like, we can use that drug in our relevance in our lives, like, okay, a lot of people use this drug and AI has hits on it. Maybe we should try this to see if it helps us with the symptom of the syndrome.
Yeah.
So do you have any studies about that?
You can break it down on a symptomatic level. So we can find the query that we would input would be find drug that treats disease, and that would be looking at symptoms that are presented in this disease and finding a drug that matches as many symptoms as possible. So we've done that before. I'm not sure if we've sent that to any physician to be tried yet, so I can't tell you whether or not it worked. But that is a step that we do. So like in the case of diabetes, that's one of the ways that we fact check and see what drugs are we finding that might work in this sense. So we can talk later and I'll show you more of what that looks like.
Just to wrap up this conversation, for the CHAMP1 community, metformin was one of our drug candidates, and luckily enough, it's a safe and effective and a very low toxicity profile. So it was something that some of our families were already on, and a few had tried. And this is probably good for the future conversation and maybe the Q&A, and tomorrow when we have time to kind of discuss whether or not there were any actionable results. Because of the safeness of the drug, did we feel like it was worth going into a clinical trial and spending all that money? So this was kind of a good thing. But this is probably something we continue further on down the line.
also for the POGS community, White Sutton community, there will be more information. We plan on contacting with him and SwampNet to get more information to you guys, so.